Hey guys, Travis Gillespie here. We're going to be working with divisibility in this section, and below there's a list of the rules of divisibility that we're going to be looking at. Just take a look at this list real quick. Notice I've listed the numbers as 2, 4, 6, 3, 5, 9. They're not in order from least to greatest. I just want to let you know if you did want to order yours from least to greatest, so 2, 3, 4, 5, 6, and so on, you can. I've listed mine in these specific groups for a reason. It makes the process a bit faster. If you've got a different method that you like, use it. So a number is said to be divisible by another number if the quotient is a whole number without a remainder. Let me say that another way. I'm going to call this the Mr. G definition. A number is divisible by another number if the result is a whole number. So let's take a look at this list and see how these values apply or these rules apply. So the rule of 2, a number is said to be divisible by 2 if that number is even. Therefore, all even numbers are divisible by 2. Let's move on to the rule of 4. The rule of 4 says the last two digits, if the last two digits of that number is divisible by 4, then the entire number, that number is divisible by 4. Let me give you an example here. So if I had 3,512, notice the last two digits, well, it's 12. So I'm going to underline 12 just so it's more noticeable. Since 12 is divisible by 4, 3,512 must be divisible by 4 as well. The rule of 6 says both rule 2 and 3 have to apply. So if either rule 2 or rule 3 doesn't apply, if it doesn't work out, rule 6 won't work either. The rule of 3 says the sum of the digits is divisible by 3. Let me give you an example here. What if I had the number 231? So 231, well, the sum of these digits, if I were to take these digits and add them up, so 2 plus 3 plus 1, well, I get 2 plus 3 is 5 plus 1, that's equal to 6. And 6 is divisible by 3. So 231 must be divisible by 3. The rule of 5 says if the number you're looking at ends in a 5 or a 0, that number must be divisible by 5. The rule of 9 says the sum of digits is divisible by 9. So what if my number was 333? If I were to add these digits up, I'm going to fix that error real quick. Alright, so if I add these numbers up, 3 plus 3 plus 3, well, 3 plus 3 is 6 plus 3, that's equal to 9, and 9 is divisible by 9. Therefore, 333 must be divisible by 9. The rule of 10 says the last digit is 0. So if the last digit's a 0, it must be divisible by 10. And the rule of 12 says the rule of 3 and the rule of 4 both apply. They both have to work for the rule of 12 to work. Here's an example. What if my number is 1,116? I'm going to look at the rule of 3 first. So the rule of 3 says I've got to take the sum of these digits. So 1 plus 1 plus 1 plus 6. Well, 1 plus 1 plus 1 is 3 plus 1, 6 here, plus 6 is 9. 9 is divisible by 3, so the rule of 3 checks out so far. 12 might be divisible by this number, but I've got to check and make sure that the rule of 4 also works. So the rule of 4 says the last two digits is divisible by 4. Since 16 is divisible by 4, the rule of 4 also checks out. Therefore, 1,116 must be divisible by 12. Alright guys, I want you to take a look at this list real quick. Notice there are two numbers that are missing. I'm just going to make some space here. Notice the rule of 7, I haven't labeled the rule of 7 or the rule of 8. Now these two numbers, they kind of have tricky rules, so I'm not going to list those rules. But if you're interested, look them up and learn them if you're interested. But what I suggest for my students, they memorize these first 8 rules here, and then when they've run through this list, whatever number they're given to find out if it's divisible by another number, if they're interested in finding out if it's divisible by 7 or divisible by 8, just try dividing that number by 7 and then try dividing that number by 8. If you get a whole number without a remainder, then that number is divisible by 7 or it's divisible by 8. Cool stuff.